Hi, everyone. Thanks for listening to this talk. As the title might suggest, it will focus primarily on the concept of a one-plan approach to species conservation, wherein in-situ and ex-situ activities are integrated, and look at why this type of approach is the way forward for species conservation planning. Today, more than 32,000 species are threatened with extinction across the globe, and as more are assessed, this number has and will continue to rise. Species conservation continues to face new and emerging challenges, and in today's world, the view that species can be effectively conserved simply by creating large areas of protected habitat is unrealistic. There is an increased need for active management and long-term human intervention in order to prevent the loss of species. Effective species conservation strategies that take this into consideration require a collaborative effort that incorporates both in-situ activities where species remain in their natural habitats and ex-situ activities where species are removed from their natural habitats or are bred in captivity. However, conservation planning for most species has followed two parallel but separate tracks, one for in-situ activities and another for ex-situ activities. In this traditional approach, the two groups of species managers are working independently to develop conservation plans for their respective populations, but this disconnect between field biologists, wildlife managers, and conservationists in the in-situ community, and zoos and aquariums in the ex-situ community, often means missed opportunities for effective species conservation planning. The one-plan approach promoted by the IUCN's Conservation Planning Specialist Group is an approach to species recovery and conservation that involves the joint development of one comprehensive conservation plan by both in-situ and ex-situ parties. A collaborative approach like this helps to facilitate the development of management strategies and conservation actions that center around a common goal, which is to create and support a viable population of a species so that it can thrive in the wild and effectively contribute to a healthier ecosystem. In Canada, a similar effort founded by Wildlife Preservation Canada, the African Lion Safari, and the Toronto Zoo is underway. These organizations, in collaboration with the IUCN's Conservation Planning Specialist Group, are working to develop the Canadian Species Initiative, which aims to address the ex-situ management needs of Canadian species at risk, to emphasize the need for one-plan approaches to effective species conservation, and to facilitate collaboration between the in-situ and ex-situ communities. Wildlife Preservation Canada is a national nonprofit dedicated to the recovery of species at risk, with special focus on those species that require some element of hands-on human intervention in order to persist in the wild. One of our target species, the yellow-banded bumblebee, is a species whose proposed management strategy includes both in-situ and ex-situ tools. So today we're going to look at how a one-plan approach to the conservation of this species will ultimately ensure that the most effective strategies for addressing threats are implemented. And we're going to come back to the yellow-banded bumblebee shortly. But first I'll say a brief bit about bumblebees in general. Bumblebees are keystone pollinators in many ecosystems. For the most part, they are native to the areas where they occur, which means that they have co-evolved alongside the plant fauna in those areas and have the capacity to pollinate most of the flowering plants in the ecosystems they support. This is incredibly important when you consider that nearly 75% of the world's flowering plants rely on pollinators in order to reproduce. Bumblebees are also extremely economically valuable because the human diet is highly dependent on pollination. About 70% of the major agricultural crops produced around the world benefit from animal pollination, most of which is by bees, and this translates to a value upwards of $170 billion annually. An easier way to consider this is that about 1 in 3 mouthfuls of the food that we eat is pollinated by bees, and a huge portion of that is thanks to bumblebees, both managed and wild. But bumblebees are threatened at a global level. Current estimates suggest that about 30% of bumblebee species may soon be at risk of extinction. The most recent IUCN Red List Species Status Report places 12 of the species found in Canada and the US as threatened, meaning that they are vulnerable to extinction. The primary threats contributing to the majority of the species declines that have been documented are attributed to 4 culprits: habitat loss and fragmentation, pesticide use, the introduction of alien and invasive species, including pathogen spillover from managed bumblebees and honeybees, and climate change. One vulnerable species under the IUCN Red List and of special concern under the Committee on the Status of Endangered Wildlife in Canada is the yellow-banded bumblebee, which, as I mentioned, is a target species for Wildlife Preservation Canada. More than 50% of its global range falls within Canada's borders, and the IUCN's latest assessment has calculated an average population decline of roughly 50% across this species' range, and in some parts of its range, the decrease in relative abundance or the loss of the species altogether is very evident. One of these regions is Southern Ontario, where the majority of Wildlife Preservation Canada's yellow-banded bumblebee programming runs. Steady declines in the yellow-banded bumblebee and other bumblebee species in this region have been primarily attributed to pathogen spillover from managed bumblebee and honeybee colonies. The rapid spread of these novel diseases across the yellow-banded bumblebee population in southern Ontario has left the region with small, isolated populations that are highly susceptible to secondary stochastic threats. Our Native Pollinator Initiative has been employing a one-plan approach to the recovery and conservation of the yellow-banded bumblebee since 2015. Through fieldwork each spring, we monitor the composition, the abundance, and the distribution of Ontario's bumblebee species, and we collect valuable information on the pollen networks and phenology in Foundress Queens through extensive surveys. We explore colony development and bumblebee nest ecology in the field using artificial domiciles, and we attempt to determine species-specific habitat preferences in order to support more effective habitat stewardship initiatives that aim to restore and enhance bumblebee habitat and help mitigate the threat of habitat loss and fragmentation. These in-situ activities have been instrumental in helping us address knowledge gaps in our understanding of bumblebee biology and population dynamics, and in recording population-level changes on an annual basis that serve to inform and update species status assessments. Through outreach and education, we increase conservation capacity through hands-on coaching, technical assistance, and the development of user-friendly training and outreach materials. We develop and deliver large-scale community science programs in targeted areas that engage participants in pollinator conservation initiatives, help us increase the geographic reach and coverage of our own monitoring efforts, and provide us with more species-specific records that help to prioritize management areas for species at risk. All of those in-situ activities play a role in the conservation of the yellow-banded bumblebee, but the potential roles that ex-situ management might serve have been highlighted, and their use proposed in management recommendations for this species. Our ex-situ activities center around the development of a captive breeding program and are designed to support in-situ efforts. Indirectly, the activities we conduct using the captive population help to fund in-situ activities and support education and outreach efforts. But, even more importantly, we are pioneering the development of captive breeding techniques that are novel for bumblebees, and in doing so, we have an opportunity to address the effects of primary threats in an ex-situ setting, and this is directly contributing to developing a management strategy for the yellow-banded bumblebee now. There are also future opportunities inherent in ex-situ management activities like captive breeding programs, and we'll take a minute to look at what these are before we wrap up. As I said, one of the benefits of ex-situ management tools like captive breeding programs is that it provides us with another means to conduct targeted research on the primary threats to the wild population. For the yellow-banded bumblebee, these opportunities are numerous, but some examples of what we have focused on in recent years include genomics work, which has helped us to determine how adaptable or resilient different populations of the yellow-banded bumblebee are, and how susceptible they are to the novel pathogens. We've also had a chance to explore the lethal and sublethal effects of different classes of pesticides on various castes within a colony, and we've been able to look at some of the natural variation we see among these castes in terms of their nutritional needs and survival rates. As for potential future benefits, these can be incredibly important for species on the brink of extinction, and in the case of the yellow-banded bumblebee and other closely related species, these tools are becoming necessary components of effective species recovery and management. Through releases that augment wild populations, a captive breeding program can offset the effect of primary and secondary threats that are contributing to population declines. Threats like these for the yellow-banded bumblebee primarily include demographic factors that affect the overall population structure of the species and reduce its adaptability and its reproductive success. To combat this, future releases from captive breeding facilities can support the recovery and management of the yellow-banded bumblebee by buying us time to fill knowledge gaps and mitigate the threats the species is facing. Through population augmentation efforts or by providing an insurance population in a scenario where maintaining a genetically diverse wild population becomes too difficult, these tools can help us maintain the wild population. In the long term, captive breeding and other ex-situ methods will likely be one of the only means to restore wild populations where they once existed and return balance to ecosystems where it has been disrupted. There are, of course, examples of species that are being conserved through either in-situ or ex-situ methods alone, but there are more examples of species that require a mix of the two, and as the primary threats species are facing become more devastating to vulnerable populations, the latter scenario is likely to become the norm. While ex-situ techniques have rarely been used for bumblebee conservation in the past, they are now considered an emerging tool with the potential to address knowledge gaps as well as help directly recover wild populations. The development of one-plan approaches to the conservation of species at risk is essential, and multifaceted recovery programs like those at Wildlife Preservation Canada are required in order to ensure long-term viability and sustainability. And with that, thank you to all those of you who took a few minutes to listen to this, and I hope you enjoy the conference.